4.6, quadratic functions in general form, which is our y equals ax squared plus bx plus c. And remember, a cannot be 0. Otherwise, if a is 0, that is simply just linear. Okay, it's just a line. It's the x squared term that turns that linear into quadratic. So what we're going to be doing today is we are going to be graphing from the general form. So we're interpreting information that is given to us by this quadratic. When a quadratic is in general form, the constant c is the y-intercept. That makes sense because in the last video we said when we want to find the y-intercept, that means that x equals 0. So if I were to say y equals x squared plus 2x minus 7, I know that my my y-intercept when x equals 0 is negative 7, because if I put in a 0 for this term, x squared, 0 squared is 0. 2 times 0 is 0. So all that we're left over with is our negative 7. So that's just an example there. If the equation is factorable, okay, the x-intercepts can be found by factoring. And this form right here is called the factored form, because the x1 and x2, they are our two x-intercepts. Now in general, a parabola is going to have two x-intercepts, but I mean, if I can just go off to the side here, go rogue a little bit, if we have a parabola that lives up here, it never touches that x-axis, so this one actually has no roots or no x-intercepts. What about our mother function, our parent graph that just touched at 0, 0? This has one intercept. And then there's the classic, where there are two intercepts. One here and one here. The equation of the axis of symmetry, the equation of the axis of symmetry is the mean of the two x-intercepts, y1 and y2 plus y2 divided by 2. That just means that here's an x-intercept and here's an x-intercept. Our axis, our equation is just, our axis of symmetry is right smack dab in the middle there. And remember, whenever we have a vertical line, it's always going to be x equals something. The equation of the axis of symmetry, that tells us the x-coordinate of the vertex. The y value of the vertex can be determined by substituting in the x value of the vertex into the equation and then solving for y. So if we know that the x value of the vertex is, say, -1, I can substitute that back into my equation and then solve for y. So these are just the general rules. I'm going to be going through quite a few examples, including some word problems. Watch the word problems and make sure that you can do some of the easier ones. But there will not be a huge focus on the actual word problems on the mastery check. The mastery check will primarily focus on graphing quadratics.